Well, let's talk about what a smart cam and why we need that one. And can we turn an ordinary camera and making it smart? That's what our next guest is going to be talking about. Because in the upcoming 15 minutes, we're going to have Alexey Likharev, the teacher and CEO of AIJ. Good day. My name is Alexey Likharev. Indeed, I am the director of AIJ Technology Company, and what we're doing is that we develop software products for video in IP networks and video analytics with the use of artificial intelligence. And today, I would like to talk about the future of SmartCam for the systems of video surveillance. Before we talk about that, let's define what smart camera is. I mean, it seems to be clear, but there's more of a vernacular without definition. Smart is a word that defines another set of cameras compared to ordinary cameras that just film the video. Smart camera assumes that it can execute additional useful function in the camera, and the more functions there are, the smarter the camera is. We could here define parallels with the phones. Phones used to be analogous, wired like cameras. Today they're digital and wireless like IP cameras. Now all of the phones are smart phones. For now, we feel like the cameras must become smart as well. So what's the main property of a smartphone today? That is the presence of the operating system on board that assumes launching some software. So we can define smart camera as a device for video surveillance with an OS installed, which allows to install and launch different sorts of software for various hands-on tasks. So let's agree on that as a definition for a smart camera. Why do we need all of that? Let's take a look at contemporary systems for video analytics. I don't want to criticize, but most of them work based on large servers with very powerful GPUs, what again makes the implementation of such systems very costly. It's hard to scale them, and the security is quite vulnerable. Servers for video analytics are quite expensive, and if you extend the camera outside of a local network, you need to provide stable broadband connection for video traffic. Remote cameras need to be sending videos down the network, where again it's possible to leak, and then you get all sorts of funny videos on YouTube. The extension of the number of cameras, specifically when they're geographically distributed, may lead to some unsurmountable requirements to computational and telecom network. If we transfer video analytics onto the device, we can radically cut the costs for servers and network, and also protect video traffic even in public networks with cryptography, with resistible cryptography. And you can install as many smart cameras as you want. Abroad, they have already installed quite a lot of smart cameras. The segment is growing by 25% every year. The leading international experts and agencies predict that over 25 of cameras installed in 25 will be equipped with AI chips. Global corporations, all of the camera producers are considering this sort of technology and solution. So let us now take a look at the approaches that exist in order to make the camera smart. First of all, let's take a look at the vendors' cameras. It's obvious that the objective of any vendor is to sell more cameras. Obviously. So, if the vendor makes the platform open, they will not be able to sell the camera. But since the main thing is to sell more cameras, smart functions will be very rudimentary and generic. They will not be able to adapt to complex tasks and business logics. So this approach is naturally confined, as 90% of market of video analytics, B2B, B2G, with a request for complex scenarios for video analytics. Certain vendors do provide the opportunity to do something like that, but to external developers, but there are a ton of limitations. So it's impossible to achieve the fully desired result. So let us now leave the vendors go. They need to go through all of the stages: denial, depression, acceptance, etc. And in the end change their approach to software and hardware of their cameras. If we return to phones, soon they will have to select either they become Nokia or they become Samsung. Well, that's what we believe. While they're thinking, let's look at the other class of smart cameras, custom cameras that can be put together based on the components in the market, such as sensors, computers, motherboards, so we can have both hardware and we can use any software that we want. But there's a problem. Processing power. Yes, this one-board cameras are fine, but they're significantly less powerful than cameras connected to a powerful mainframe. So we have two ways to go there as well. We can try to increase productivity using compact accelerators. Yes, they will give some sort of productivity boost, but they will not ever catch up the servers and GPUs. So we can launch only simple scenarios on these types of devices. And of course, this sort of accelerators are making a device more expensive, so this approach is sustainable but limited. Second approach is optimization. A neural network is something very universal that can be trained to pretty much anything. In order to have that, it needs to be a bit too much. Like our brain, we can learn anything, but the price is that we're wasting so much energy just to lie on the sofa, and the fly with a facet vision functions very well to execute a very simple task that it must do during its short lifetime. So, no matter what scenario for video analytics is, we can always try to optimize that to lower the demands for the productivity of the gear. Hardware. So as odd as it sounds, the major rule for neural networks optimization is to reduce the use of neural networks wherever it is possible. For example, swapping them for computer vision. We can, for example, shift the computer vision focus so the network doesn't have to analyze the high definition, or we can swap recognition for tracking, which is also very efficiently decreasing the use of resources. As for neural networks, it's possible to execute quantization with different levels of precision, or we can do reduction, removing neurons and connections that don't make impact on the final result. Also, when we optimize, we need to take into account the hardware platform for which we do the optimization, understanding how, using different architecture, we can implement working with memory so that we would not waste time on allocating memory blocks, and we can launch parallel computations more efficiently. We need to take into account that this sort of work is quite creative, and it requires a lot of experience. So it's trial and error, but the result justifies all of the investment. So we can increase productivity by the factor of 30 without the loss of precision. Since there are a ton of deployed systems for computer vision, the most important task is to make a camera smart, so that we would not to reinstall all of the hardware. So we can connect to a camera a simple one-board device so that the usual camera becomes a smart camera, so that we can save a bit of money, which is always great. All of the above has been implemented on our platform for video analytics. The platform is called Kamai. It can work both as an ordinary server-based video analytics, but it's mostly focused on the expansion of the smart camera use. In order to video analytics, the platform itself contains the system for protection of video traffic with the use of cryptography. And the system has also tools for distribution of video that helps us to create flexible, territorially distributed projects. In our projects, we take the scenarios for our clients and, using the real environment, with the current information systems, we use our very own datasets, create new datasets, train neural networks with them, and with the use of math, optimize them, and publish the result at the software platform of the product. With using that software, we optimize hardware to provide maximum productivity and edge computing. This sort of approach decreases capital expenditures and operational expenditures while helping to reach KPIs. Let's take a look at a number of examples. I mean, there are a lot of examples, but we have specifically selected those for the presentation that are hard to implement without a smart camera. So on this particular slide, we can see a video analytics on a bus. We have connected one board computer to the camera in the bus. So we can detect people coming in and going out, and we can actually compare the number of exiting people with the number of validated tickets, and if there's some critical threshold achieved, we can invite the controller into the bus. So it's an important critical information. We don't need to send that much traffic from a bus via mobile network. Let's return a little bit. Camera on the bus. There are 5 cameras in the bus, and there are thousands of buses. The bitrate of a camera is a number of megabits. So a smart camera allows avoid sending tons of gigabit of traffic per second from buses. For example, it would be more convenient to place a server in every bus, but we don't have power, we don't have space for that. And that will make a bus so much more expensive. So let's look at the next scenario. A smart camera that it's installed into the traffic light. It detects and tracks people passing by the street, crossing the street, to actually determine the mode of the frequency of the traffic light change. Again, installing a server will be too expensive. So this is another real-life example of how the smart camera can be so much more useful. Traffic lights are not only looking at the pedestrians, but also at cars, so we can also check information, collect stats, and see events like accidents on the road. At the highway, smart cameras can detect the class of a vehicle, average speed, and provide information on speed violations. For example, certain roads are not, for example, trucks are not allowed on certain roads. Also, we can estimate the quality of the road and plan repair works. The country is big, the broadband coverage is not great sometimes, so video analytics on device would be much more appropriate here. We can also track physical indicators, vitals of the person, temperature, attention span, especially if we have infrared sensors, or even pulse. That is especially important for drivers who have been driving for a long time. Again, smart cameras are compact and anonymous, so they can prevent incidents while solving complex technical tasks. And they're not expensive. So, therefore, I conclude, and let me invite all of you to work with us. We're now expanding the team, growing rapidly. We have a lot of projects, we're ready to partnership, and we're happy to talk to businesses and individual developers, data scientists, engineers. I mean, I think working with us is exciting. Please join. Well, thank you so much. It was a beautiful presentation. I mean, it has been so coherent. I don't think there are any questions. Thank you so much once more. Indeed, a smart cam is essential. Thank you for sharing your ideas on that. Dear friends, we continue today's conversation.